Okay, next one. John stands 170 meters from a cliff and shouts. So that's 170 meters. How far does the sound travel to his ear? Well, it has to get to the wall and back again. Therefore, the distance covered is 170 times 2, which is 340 meters. When will he hear the echo? Speed equals distance divided by time. So we're trying to find time this time, but the speed is 340 from up here. The distance is also 340. Therefore, a bit of rearranging gives us that the time will be 340 divided by 340, which is just 1 second. Question 5. Definitely one to label the diagram and draw certain things on it. So it says a man standing at Y, 900 meters from this wall. And you get used to doing this in exams as well. Don't be afraid to label diagrams. Fires a pistol. Speed of sound in the air is 300 meters per second. What is the time interval between the two reports? Reports means it's the sound of a gun by a man standing at X, 300 meters from Y. Now, that also then means that this must be 600 meters. Now, two ways of doing this. Hardest way to do it is you can first of all work out the time for the first sound that this person will hear. So when the gun's fired, sound travels like this, 300 meters, he will hear it, the length of time that takes. The second sound then will be the one that travels past him off the wall and he hears the echo reflection of it. We could work out that distance, work out the time, and then find the time difference between the two. But if we just look at, let's say, travels along here and then he hears the first sound. After that, the sound has to travel from here and back again, which is a total distance, an extra distance from here to the wall and back again of 1,200 meters. And we can just then put that in to our equation. So 300 equals 1,200 divided by t. 300t equals 1,200. T equals 1,200 divided by 300, which is just 4 seconds. If you did it the other way, you would have got he hears the first sound 1 second after the shot, the next one 5 seconds after the shot, so the difference is still 4 seconds. Question 6, Coast Guard. There's the Coast Guard. Here's a distress rocket from someone who's sinking on a boat. So they fire a little flare in the sky, like a little firework, and the sound then travels like this. Time is 5 seconds. Speed is 330 meters per second. And this is actually a little bit of a trick question. There's no echo here. That isn't reflecting off anything. It's going straight from that burst to the Coast Guard's ears. Therefore, it is just speed equals distance divided by time. We don't have to do anything with those numbers. Time is 5 seconds. So 330 times 5 gives you the distance. Distance is then 5 times 330, 1650 meters. Last one. An observer sees a firework, so this is our little observer, explode 1 kilometer east, so that's 1,000 kilometers, and that takes, here's our little firework again, looks more like a palm tree, that takes 3.1 seconds. Meanwhile, over here we have another firework, and that takes just a time of 2.9 seconds. Calculate the speed of sound. We could do this for each of them, so that's 1,000 meters as well. So if we do the first one, or the one on the left hand side, we can do speed equals distance divided by time, which is 1,000 divided by 2.9. Type that into your calculator and it gives us the speed of sound is 345 rounded up meters per second. Meanwhile, the blue one, same thing, speed equals distance divided by time. speed equals distance, same, 1000 divided by time, 3.1, 1000 divided by 3.1 gives us 323 meters per second. Why is the speed different? Why are the two times different? The reason for this is sound travels in air, and air is not always still. Therefore, there is a wind blowing that kind of assists the red firework there, okay, because the wind must be blowing in this direction, which carries the sound with it, which is why this is less rather than this sound here. Remember, it's trying to travel in this direction, and therefore it takes longer because it's traveling against the wind towards the east. Okay,